In the last few videos, we learned how to turn LEDs on and off using a TCP connection on the Zynq FPGA. In the most recent video, we also learned how to create a basic Hello embedded web server on the Zynq FPGA. If you haven't watched that video, it's better to visit it first. Now, in this video, we are going to combine both of the previous tasks to create an embedded web server that controls the LEDs. In order to create an embedded web server, it is basically divided into a front end and a back end. For the front end, we use HTML, Bootstrap, a CSS library for styling, and jQuery, a JavaScript library. For the back end, we use Python with the Flask framework. The jQuery and Python code can exchange data using HTTP. The Python code reads the current state of the LED and sends it to the jQuery code to be displayed in the HTML text. The jQuery code reads the input from the HTML button and sends a command to the Python code to either turn the LEDs on or off. There are two types of HTTP methods that will be used in this project: HTTP GET and HTTP POST. The HTTP GET method is usually used to retrieve data from the server, in other words, to perform read-only operations. The query parameters are sent in the URL, so they are visible. In contrast, the HTTP POST method is typically used to send data to the server, in other words, to perform create or update operations. In a POST request, the data is sent in the body of the HTTP message, so it is not visible in the URL. Common use cases of HTTP GET include searching, loading a page, and filtering content. Common use cases of HTTP POST include submitting forms, uploading files, and creating resources. Because the data is not visible in the URL, HTTP POST is often safer when sending passwords, private information, or when creating or modifying something on the server. Now, let's get into the coding. I will walk you through the step-by-step process to build a web interface for controlling the LED. Here is the console of my FPGA board running Linux. First, make sure you already have the PYNQ overlay files for the GPIO that control the LED. If you haven't done this yet, you can refer to my tutorial on how to create a custom PYNQ overlay. You can find the link in the description. Next, create a folder for your web project. Inside it, create two folders, static and templates. Next, inside the templates folder, create the index.html file. Next, upload the Bootstrap and jQuery libraries to the static folder. You can find them in my repository. The link is in the description below. Now open the index.html file. We're going to build the structure of our website step by step, starting with a simple Hello web page. Add a title to the web page, and then import the Bootstrap and jQuery files that we uploaded to the static folder. For now, just add a simple Hello text. Now that we're done with the front end, create a file named app.py in the parent folder, outside the templates folder. Open the file so we can start building the backend. First, import the required libraries. Then add a route for the index page. Here, we specifically define the HTTP method as GET. When there is a request from the web browser, the index.html file will be sent. Next, add the main Python code to start the server. Now, let's try to start the server. Then, open a web browser and enter your board's IP address. Here is a simple hello text displayed as expected. Next, we can start creating a layout using the Bootstrap grid system. Start by adding a container fluid class to wrap your content and make it responsive across the full width of the page. Next, add a row with the h100 class to create a full height row inside the container. Next, add a colsym4 column and use the bg primary class to set a background color. This will help you visualize the column's size. Go ahead and restart the server to run it again and see the changes. This gives us a single column that spans 4 columns in width. Let's add more columns and see how the layout changes. In Bootstrap, the grid system is based on 12 columns, so a single row can contain up to 12 column units in total. Here, we're using 3 columns, with each one taking up 4 units, adding up to the full 12 column width. Restart the server and open the browser to see the changes. There are now 3 columns, each taking up 4 units, which together make a full width row of 12. Now delete the second and third columns. We only need 1 column with an offset of 4 units. Restart the server and open the browser to see the changes. So we only have 1 column, but it is offset by 4 units, so it appears in the middle. Next, add an HTML button that will turn on the LED. By default, it will appear left-aligned. To center the button, wrap it in a container or a div and apply the text center class to that container. Next, add another HTML button to turn off the LED, along with a text label to show the LED status. Next, add the MyAuto class to vertically center the content within its container. Go ahead and remove the background color. It was just there to help you visualize the layout structure. Next, add padding to the top and bottom of the second button to create some space, making the layout clearer. This completes the front-end development process. If you're interested in learning more about basic Verilog RTL circuits, integrating an ARM processor with your RTL module as part of a system on chip, and working on a neural network project, be sure to check out my online course through the link in the description. By enrolling, you'll also be supporting this channel and helping to keep it running. Now, let's move on to the backend. First, add a function to program the FPGA and set the LED to the off state. Be sure to call this function before the main function. Next, create a function to handle HTTP GET requests from the front end to check the LED status. It reads the GPIO and sends the corresponding result back to the front end. Now go to the front end and add some JavaScript. This code will run when the page loads, sending a request to the backend for the LED status and displaying the result in a text element. Now, to restart the server, we need to log in with sudo first. Why? Because this time we have to program the FPGA, which requires root permission. Refresh the browser and you should see the LED status displayed. Now, create a function to handle HTTP post requests from the front end to control the LED. This function will read the command from the front end, update the GPIO to turn the LED on or off, and return the updated state to the front end. Now, go to the front end and add some JavaScript. When the On HTML button is clicked, the code sends an HTTP post request to the backend containing the On command. The same applies to the Off button. When clicked, it will send the Off command to the backend. The updated LED state will be displayed in the text element. Restart the server and refresh the web browser. Now the front-end interface is fully functional and can control the LED on the FPGA, allowing you to turn it on and off seamlessly. If you look at the FPGA's terminal, you will see the commands sent from the front end printed there. Also, if you open the console in your web browser, you will see the LED state sent from the backend. This functionality is very useful for debugging when something goes wrong. If you enjoyed this video, don't forget to like, comment, and share. See you in the next one.